Now let's learn about something called the atomic mass. It sounds similar to the mass number, but it's not. On the periodic table, you will find the atomic masses. Usually, they are the numbers with digits after the decimal point. If you have a periodic table in your hand, or not, go to the ebook and open the periodic table, or just type the periodic table of elements on Google and search for images. Here is an example for chlorine. This is the value you will find on the periodic table for chlorine, and it's called the atomic mass. What is the atomic mass? The atomic mass is the weighted average of the masses of all the isotopes that make up that element, in this case chlorine. What's the weight average? For example, if I say that there are two people, one weighs 100 pounds, the other weighs 200 pounds, what's the average? You would add them up, 100 plus 200, that's 300, and divide them by 2, the total, which would give you 150. Well, what you just did was found the simple average. But what if I say there are 5 people who weigh 100 pounds and 15 people who weigh 200 pounds? Now I ask you, what's the average of this population? Well, in this case, you have to realize that 25% or 5 out of 20 weigh 100 pounds, and 75% or 15 out of 20 weigh 200 pounds, and you have to take that into account before you find the average. So what you are taking into account is the weight carried by each group, the 25% and the 75%. Similarly, here we are going to be finding the weighted average of different isotopes, because not all isotopes are going to be found in the same abundance. For example, chlorine has two isotopes, chlorine 35 and chlorine 37. Um, Chlorine on the periodic table, if you look at it, has a number of protons, or the atomic number equals to 17. So chlorine 35 has how many neutrons? 35 minus 17 is 18 neutrons. And how many neutrons are there in chlorine 37? 37 minus 17 is 20. So you have two isotopes, one with 18 neutrons, one with 20 neutrons. But both of them do not occur in nature at a ratio of 50% to 50%. Instead, you have 75.77% of chlorine 35 and 24.23% of chlorine 37. Similar to how I gave you an example of there being 25% students who weigh 100 pounds and 75% students who weigh 200 pounds. So we will be taking the weight average of these two values, the percentages, and these percentages are measured numbers. You must count the sig figs here. So we have 4 sig figs here and 4 sig figs here, and you must convert the percentages to fractions by dividing the percentages by 100. 75.77 divided by 100 will give you 0.7577, and 24.23 divided by 100 will give you 0.2423. The 100 that you use to divide is an exact number, so do not count the sig figs there. Once you get the fractions, multiply the fractions with the masses for each. So for chlorine 35, the mass is 35.0 AMU, and for chlorine 37, the mass is 37.0 AMU. When you multiply that, you get two new numbers, and now you simply add them. This is how you find the average atomic mass of a given atom. There is a problem that I want you to try, and that problem has to do with neon. Neon is an element on the periodic table with 8 protons. So neon 20, 21 and 22 are the 3 different isotopes of neon, and the mass is given for all 3 are 20.0 AMU, 21.0 AMU and 22.0 AMU respectively. Here are their abundances, their relative abundance. All put together, their relative abundance must equal 100. So what is the atomic mass of neon? So what you will do is you will divide each value by 100, and the fraction form you get you will multiply with their respective masses and then you will add up their respective masses. So do this problem and solve this problem correctly. You will see other problems of this sort going forward.